This is Recognizing Applications of the Pythagorean Relationship, Lesson 27b. Remember, if you've missed or skipped any of the previous videos, you can check this video's description for links. And I really want you to watch video 27a first before you watch this one. There's a link in the description. Look for G.E.D. Math 27a. It explains the Pythagorean theorem before we get into this with actual problems. We can use a squared plus b squared equals c squared, the Pythagorean theorem, to solve real-world problems of distances, building construction, and right triangles. And don't assume a triangle is a right triangle. Look for that little 90-degree box in an angle or some other indication that it is a right triangle before using the Pythagorean theorem. And remember to look for that 3, 4, 5 and their multiples in right triangle problems. We talked about this in the previous video. 3, 4, and 5 is special to the Pythagorean theorem, and they're multiples. And if you're confused about these square roots, you need to watch video 20b, where we talked about square roots, okay? So a squared plus b squared is going to equal the hypotenuse c squared, okay? So here we've got a diagram, and it shows Emma's house, and it shows that Elm Street is 375 yards this way, and then Main Street is 500 yards this way, and then there's her school. She also could cut across the park. That would be the hypotenuse of this right triangle, wouldn't it? If Emma walks in a straight path across the park to and from school on Monday, so that's how she gets to school and back on Monday, and then she walks to and from school on Elm Street and then Main Street and then back, what is the difference in distance between the two round trips? So the first thing we need to notice is that it says it's round trips. So it's not just one direction. She's going to school and back on Monday, and then she's going to school and back on Tuesday, okay? So we have one problem to solve, two problems to solve, and then we need to find the difference between them to find out the difference between the two round trips. So if she were to go from Elm Street to Main Street, Elm Street was 375 feet, or yards, I'm sorry, and Main Street was 500. So we would add those together, wouldn't we? To find the distance, we would add the 375 and the 500, and then she's at school. But we need to multiply it by 2 because it's a round trip. So 2 times 375 plus 500, we do inside the parentheses first. So we have 2 times 875. That comes out to 1,750 yards. So we know that her round trip taking the streets was 1,750 yards. Now, let's find out about cutting across the park. This is our A, this is our B, so we need to do A squared plus B squared, and that's going to tell us C squared, isn't it, for our hypotenuse? So we do 375 squared, which is huge. It gives us 140,625. And we do 500 squared, which gives us 250,000. We add these two together, and we get 390,625. And to remove this little 2 exponent from the C, we need to put a radical sign around this side. See? And then we find the square root of that number, and we get 625. Now, because it's a round trip, that's just one hypotenuse. Because it's a round trip, we need to multiply it by 2, and we get 1,250. The difference between them, we take this amount and subtract this amount, and we find out that by cutting through the park, she's going to save 500 yards of travel to and from school. See? So she saves herself a lot of walking time by cutting through the park. All right, now this one says, Bob wants to hang holiday lights from the top of a 12-foot pole to the ground. And if each string of lights angles 6 feet from the bottom of the pole on the ground, how many feet of lights will he need for each length? So here's our A, here's our B. So to find C, we just need to plug it into the Pythagorean theorem. We get 6 squared plus 12 squared equals C squared, our hypotenuse. So that means 6 times 6 is 36, 12 times 12 is 144. We add them together and we get 180. We remove this little 2 exponent from the C by putting a radical sign around the 180 and squaring it, and we get approximately 13.4 feet of lights for each length. On the calculator, you just put in the square root symbol, then the 1, the 8, the 0, and the equal, and then it'll give you that approximation. It came out a little bit longer. I just rounded it off. So if we know it's about 13.4 feet for each length, and he wanted to put a bunch of them going around so it made the shape of a cone or the shape of like a tree, he could just multiply each length that he wants. So let's say he wanted 10 strings of lights going around. He would just multiply the 13.4 by 10, wouldn't he? Then he would know how many feet of light he needs to buy, right? Of lights, all right? Okay, now take a look at this. We've got a little north, south, west, east thing going on here. And I taught my kids when they were little that north is up, south is down, and we go across. That way, if you can remember we go across, you know that that's west and that's east, okay? 2 trains leave a station. One, the red one, goes north, and the other goes west. The blue one is heading west. After 30 minutes, they've each traveled 46 miles. So here's the station, and after half an hour, this one went 46 miles and this one went 46 miles. How far apart are they from each other to the nearest mile? So we're not going to add the 46 and the 46 to find out how far apart they are from each other, because that's a right angle. We need, as the crow flies, how far are they from each other. That's the hypotenuse, see? So we can do a squared plus b squared is going to equal c squared. We do 46 squared plus 46 squared is going to equal c squared. 46 times 46 is 2,116. We get the same thing again. We add these two together and get 4,232. We remove the little 2 exponent by putting a radical sign around this number. We find its square root, and we get 65.05 miles. So we know that they're about 65 miles from each other at this point. That's a big difference from 46 plus 46, isn't it? So as the crow flies, they're about 65 miles apart, all right? Now we've got a map of a bunch of towns. Here's the town of Arlington, and 24 miles away is the town of Bedford. We can see 20 miles away is Canton, and then from Canton to Danville is 16 miles. From Bedford to Danville is 18. And the question is, what is the straight line distance in miles from Arlington to Danville? So from Arlington to Danville, it wants to know this. And look, we have a right triangle and a hypotenuse. See that? So we can do 24 and 18. So we have 18 squared plus 24 squared is going to equal that distance, that hypotenuse, c squared. 18 times 18 is 324. 24 times 24 is 576. We add them together and get 900. We remove this little 2 exponent by putting a radical sign around the 900 and finding its square. The square root of 900 is 30. So we know the distance between Arlington and Danville is 30 miles if you cut across that way. See? Now here's one that's pretty interesting. We have a tree that was cut down. And Bob cut down a tree. It was dead. It needed to go. Okay? So he cut it down 4 feet above the ground. So he cut it right here at 4 feet up. The top of the tree fell 13 feet from the trunk and hit the ground right here. So it's on an angle. See that? How tall was the tree before he cut it down? Now, we can't just add the 4 feet and the 13 feet because that's an angle. You can't add this side and this side to get the hypotenuse. You have to square this side and square this side to find the square of that side, okay? So what we need to do is 4 squared plus 13 squared. We get 16 plus 169. We add these two together and get 185. We remove the little 2 exponent by putting a radical sign around the 185. Square root of 185 is about 13.6 feet. But we're not done. We know that this is 13.6 feet. It wants to know how tall the tree was before it was cut down. So that's not the height of the tree. The height of the tree is this plus the 4-foot trunk, isn't it? The stump. So we have to add the 4-foot stump with that 13.6 feet, and we get about 17.6 feet tall. We add the remaining 4-foot stump to that hypotenuse, okay? So that was kind of tricky, wasn't it? You can't just add those. We have to do the Pythagorean Theorem, then find out what the hypotenuse is, and then add it to the stump to find the height of the tree. It must have been like way up here before it was cut down, right? All right. Now, we can find the distance between 2 points on a coordinate plane. That's the distance formula. We talked about this in video 22E, and I showed you how to use the distance formula to find the distance between 2 points on a coordinate plane. But using the Pythagorean theorem can be much faster. If we have ordered pairs, x is 3, y is 2, and x is 9, y is 10, that puts a point here for the 3, 2, and a point here for the 9, 10. All we have to do is connect them into a right triangle and use the Pythagorean theorem, and we can find the distance of this slant, of this slope right here. This is 6 units this way, this is 8 units this way, so we have 6 squared plus 8 squared is going to equal that distance between those 2 points. We do 6 times 6 is 36. We do 8 times 8 is 64. We add them together and get 100. We remove this little 2 exponent by putting a radical sign around the 100 and finding its square, which is 10. So we know the distance between these 2 points is 10. Let's try that again. What is the distance between the 2 points? So we have point x is 2, y is 8. That's right there. And we have x is 6, y is 1. We want to know the distance between these 2 points. So what we do is we make a right triangle. We connect the 2 points, and then we make a right triangle. We count the units here. There's 7. We count the units here. There's 4. So we know we've got 7 squared plus 4 squared is going to equal c squared. 7 squared is 49. 4 squared is 16. We add these two together and get a 64. We remove this 2 exponent by putting a radical sign around the 64 and finding its square, and we get 8. So we know the distance between those 2 points is 8. See? Okay, so you should now be ready to do the skill focus on page 315. If any of this confused you, go back and watch these side videos. These grade 8 math videos and these Algebra I videos are really helpful. And you can review the square roots video 20b, or the previous one we just did on Pythagorean theorem. And you can review 22e, where we talked about using the distance formula to find the distance between 2 points, okay? Using x and y ordered pairs. Our next video is going to be organizing information. We're going to be making a list or a chart to help us solve some problems. And that's video 27c. You want to try to understand this as much as possible. We only have a couple videos left before the GED playlist is finished, and you'll be ready to take the GED test, okay? So try to watch these side videos as much as possible. I keep saying they're expecting you to learn all of high school algebra and geometry in just a few lessons, where regular students get a couple years to learn this stuff. You can't learn to play the piano or a guitar in just a few lessons, as well as someone that would have years of practice doing it. So give yourself a chance and watch as many side videos as you can, all right? I'll see you next time. Have a great day. Bye.